Hello, statistics student. This video is for chapter 1.1 part 2. We will look at some example to understand the 6 terms that we have introduced in part 1. The 6 terms are population, sample, parameter, statistics, data, and variable. Okay, so quickly, population is the target group that a researcher want to study. Sample is the subcollection of the population because sometimes it's not possible to study the whole population, and also is more, time consuming to study the whole population. Sample has to be representative for you to use it, and a particular use of a sample is you calculate a numerical summary of a sample, and you will use it to predict the parameter of the populations. So parameter is for population, statistics is what you calculate from your sample. Variable is the name of the data that you are going to collect. Data are the actual data. Okay, so we have a few examples here. Example 1, 37 students are randomly selected to find the proportions of students who prefer a synchronous mode of teaching. So obviously these 37 students were surveyed, right? And then the goal is to see the percentage. Now, in statistics, this term proportion is similar to percentage. So in real life, we actually say percentage. But in statistics, we call percentage a proportion because this is represented in decimal form. So if we say if you find a percentage of 25%, a proportion would be 0.25. So it's just a special word that statisticians use. So we want to find percentage of students who, out of these 37, who like asynchronous teaching. So in this case, what is the population? They just say 37 students are randomly selected. So it must be from a bigger population. So you would say all students, right? You did not interview all of them. You randomly select some. What is the sample? The samples are the 37 surveyed. So if you do a survey or you invite someone in the population to participate in a study, that is your sample. Okay. Of the 37 students surveyed, 14% prefer asynchronous teaching. So the number, I think it should be 14%. So the number 14%. So this is the summary of the 37 students, right? So these are the summary. So 14% is calculated from where? It's from the sample. So it is a statistics because this 14% is calculated from the sample because it's from a sample. 14% is a number that you calculate. And in layman's term, we call it for the 14% a percent. In statistics, we call it a proportion, and sometimes we represent it as 0.14. Okay. C, the average annual income of all residents in the city is 34,000. So notice they say all residents in a city. So the number 34,000, is it a parameter or a statistic? I would say it is a parameter because when they are saying all residents in a city, it seems like they did not interview just some of the residents. They actually interview everyone. There is reason to believe that this all residents is the population. So this number is calculated from population. So this is a parameter. And this particular study will not be a statistical study. It's just a data collection kind of exercise. D. A sample of 45 college graduates is surveyed and their average annual income is $34,000. So sample, and you do not collect everybody. You do not you not survey all of the college graduate, only a sample of 45s, right? So you will see that the size is specified is smaller. Is also they use the word sample and they use the word survey. You can see this is a sample and you calculate their annual income. So this 34,000 is a statistics because this 34 is an average that you calculate from all of these 45 students in the sample. So it is from a sample. So we call this number a statistics. So the most common statistic that we calculate from samples are either average or a proportion. Okay, proportion will be counting something. Average is a number that is the average of the sample. The next example is a summary of all the terms. So let's look at this example. A study was conducted at a local college to analyze the average cumulative GPA. So we want to know average cumulative GPA of students who graduated last year by surveying a randomly selected group of students who graduated last year. So we want to know the overall GPA of all the students that graduated last year, but we can't interview everyone, so we just survey a randomly selected group of students. So the cumulative GPA of students who graduated last year is, so determine the key terms. So what would I say these? So this would be a variable, right? Because this is the name of the data that I will collect. Cumulative GPA of students who graduated last year. That's what I want to find out. So that's a variable. It changes for every student, but we can calculate average, right? But to calculate average, I have to have the data for every single person, but I can. So we do a cumulative GPA of a sample of students graduated last year, and we have 4 numbers here. So the actual number itself is data. The group of students being surveyed would be a sample, right? They didn't say how many were surveyed, but this is a sub-collection. College Registry published that average cumulative GPA of all students, could notice, all students who graduate from the college is 3.1. Somehow, someone actually know all the students' average GPA and they publish the average GPA and it is 3.1. So this number, 3.1, is a parameter because it's from the whole population. Only the registrar, if they're willing to do, can do it. E. All students graduate last year in the local community college. So that would be the population, right? You are trying to study them. So that would be the population. I forgot to put the line here. F. Average cumulative GPA from the sample of the students is 3.32. So this is also average GPA, but you calculate from a sample. So this number of 3.32 is a statistics. So you can see the statistics is different from the parameter. You can use it to estimate it. It's quite close, but it's not exactly. So the sample shows 3.32, but the actual parameter, the actual average is 3.1. Okay, so this is how you distinguish the 6 terms. Another one, a study on car safety are performed. A sample of 70 cars with dummies in the front seats were crashed into a wall at a speed of 35 miles per hour. I think the Consumer Reports usually test cars like this to rate their safety or give them a safety rating every year. So they would crush the car into a wall with dummies sitting in the front seat. We want to know the proportion. So proportion, remember, is percentage of dummies in the driver's seat who would have had injuries if they have been actual drivers. For each car crash, the head injury condition, that means if they were injured or not, of the dummy is recorded. So the population is what? The population is all cars, right? But did we study all the cars? Did we use all the cars to crash into the wall? If we do that, there will not be any car left for us to drive, right? So no, they do a sample. They use a sample. The study use a sample of 75 cars. 75 cars. So how do they pick them? It is a sample. Are they representative? We don't know. What are the parameter? What is the parameter? The parameter would be how many or what is the percentage that has injury, right? Injury percentage, head injury percentage. So for every car, you record, well, I should say proportion, because in statistics, we use the word proportion. And the statistics is a head injury proportion of all the car. Also, we don't know. They did not tell us how many. So this would be from the 75 car, right? Would be from all car. Oh no, parameter is from all car. And the second statistic is from the 75 cars. Okay, remember, from the sample, you calculate the percentage. That is a statistics. Variable is the injury condition, that the data that you are trying to collect, the name of the data that you're collecting. And in our case, they're collecting whether it has injury, yes or no. And the data would be all the yes or no. Yes, no, less from each car, right? So that would be 75 yes or no. So that is all the example that I have in the notes. One thing that you can do is I recommend you to look at the book. In chapter 1.1, example 1.4. So you should look at this example, and you can also use show solutions to get more practice on the understanding the terms in 1.1. Okay, maybe we'll go through this in class.